Welcome to part 2, where we're going to copy bricks to a point cloud. You're now going to create a cloud of points that match the shape of a particular piece of geometry. You are then going to instance the bricks to the 3D grid to create a brickified version. The instancing is generated by packing the brick geometry and then instancing them to the points. Okay, so we're going to go into this view here. Let's zoom out a bit. And we're going to go Tab and type Test. There's a whole bunch of test geometry objects that Houdini comes with, and we're going to pick the rubber toy and press Enter to place that at the origin. Now, if we double click to dive into there, we can change the uniform scale to 3. What's happening now is that the model is underneath the ground. So let's press N to select everything. Let's go Tab, Match, Size. And what we need here is Y to be set to minimum, and that will place it up above the ground. Now what we want to do is fill this shape with points, and there's a very simple tool for doing that. We're going to right click, and we're going to go Points from Volume. We're going to place that down, and then set its display flag. If we zoom in, you'll see that inside the geometry are a ton of points. Let's press 2 and then N. You can see all those points. And we have the ability to adjust these later, and we'll do that. What we want to do now is connect these points to the brick that we have. So let's go up to the object level, and we have the single brick, and then we have this piece here, which we could probably simplify by just calling rub toy. So we go single brick and rubber toy. So let's select the single brick. We're then going to go to the modify shelf, and we're going to go copy to points. We're then going to select the rubber toy as the points and press Enter. And this takes the two objects that we had before and puts them into a single node, which we're going to call Brickify. And inside here, you have the brick. You can right click on there and say Hide Inputs. So that simplifies it a little bit. And then we have the test geometry with the match size and the volumes here. Now when we look into here, we notice that the bricks are sort of overlapping. They're not doing what we want. And the reason for that is that the volume of the points is 0.1 and we need it to be 0.2. Once we do that, now it's thinking hard to do it, so it takes a little while. One of the options we need to do is on copy to points, we need to do pack an instance. When we do pack an instance, then if this is set to 0.1, see how it's very fast. If it's set to 0.2, it's also very fast. So it's much faster when you're using that particular option. Now, if we go to, let's say, the test geometry here, and we change its uniform scale to 4, you'll see that it got bigger, and there are now more bricks. More points, more bricks. You can actually middle click here to see points. Whereas when we only had a size of 3, there were 3,000 points. So we were able to double the number of points and get a good result from there. So the next thing we want to do is we're going to, in here, we're going to go Tab, Color. We're going to put a color node right here in between there, and we're going to set that to red. That will take, the points will be colored red, and then they will in turn color the bricks. Now that is actually the feature, the reason we had to go back to the OpenGL viewport render, because the Vulkan render will not show that to you here. So it's important to have that here. Okay, so let's just look at that. We've got our 3D shape. Everything's looking good there. We've got our nice clean little network in which we will begin to work with, and ultimately we will turn this into a tool that can be used over and over again. What we can do here is we can get into here. Let's move the rubber toy over here, and let's press Tab, Switch, and place that right in the center of there. And that will allow us to switch between that shape and that shape. Okay. Now, if we want to, we can now go to the create shelf, and let's get this platonic solid and drag this right into the scene here. We can plug that in here. We're going to change that to, say, Utah teapot, and we're going to set the radius to 4. Okay. Now, with this feeding into there, we can now take the switch node and we can change it to 1, and it will go to the teapot. And as it goes down the chain, it's definitely feeding the teapot, but it's not getting all of the pieces. And so what we might want to do is, let's check the match size and see what's going on here. Oh, we probably want to delete all of this and say primitives there, or guess from group. And that will allow it to handle different kinds of geometry than what we had before. So that's important. And then in the copy to bricks, there's only a certain number of bricks that are allowed. We want to delete that, and that will give us a better look at the shape there. And so now we can go between 0 and 1, and the result comes out accordingly. We are getting some display issues of displaying, because we've got lots of polygons being displayed with this. We can press D. We go to optimize here. We can maybe change that to 80 million. And if you do that, you see, yeah, you can see the whole geometry there. So that's sort of affecting it there. You could also take away the distance-based culling altogether, and then it won't make a difference. So anyway, that's an option there. So now you've got a system where you can use this switch node to go back and forth between option 1 and option 2. And that is sort of the power of proceduralism beginning to show itself. And let's keep going.